Question 1. By using guess and check, it turns out that the carrots that each rabbit must get must be 1, 3, 5, and 7. Because 1 plus 3 plus 5 plus 7 gives us 16 carrots. For question 2, if we give each child 3 candies, the total number of candies given would be 15, but the number of candies each child receives must be different. So we can take away a 2 from here, giving us 1. We take away a 1 from here, giving us 2. And this would remain the same. And we add a 1 to here, giving us 4. And we add a 2 to here, giving us 5. Let's check our answer. 1 plus 2 plus 3 plus 4 plus 5 is 15. Therefore, the answer would be 1, 2, 3, 4, and 5. For question 3, we notice that the page numbers must differ by 1. So let's try 10 and 11. But 10 plus 11 is equals to 22, which is not equals to 25. So we try 12 and 13. And this time round, 12 plus 13 is equals to 25. Therefore, the two facing page numbers are 12 and 13. Similarly, for question 4, the two facing page numbers must be 4 and 5. For question 5, let's assume the three numbers are the same, so they would be 9, 9, 9. But they must be different, so we take away a 1 from here, giving us 8, while this remains the same, giving us 9, and we add a 1 to here, giving us 10. Now, 8 plus 9 plus 10 gives us 27. Therefore, the three numbers are 8, 9, and 10. For question 6, we can assume the 5 numbers are the same, which gives us 10, 10, 10, 10, and 10. However, we know that they must be different, so we can take away a 1 from here, giving us 9, take away a 2 from here, giving us 8, and this remains the same, and we add a 1 to here, giving us 11, and we add a 2 to here, giving us 12. So now the numbers are consecutive, and 9 plus 8 plus 10 plus 11 plus 12 would give us 50. Therefore, the 5 numbers are 8, 9, 10, 11, and 12. Again, for question 7, let's assume the 3 numbers are the same, which gives us 5, 5, 5. But we know that they must be different, so we can take away a 2 from here, giving us 3. And 3 is an odd number, and this remains the same. And we add a 2 to here, giving us 7. Now 3 plus 5 plus 7 gives us 15. Therefore, the 3 odd numbers are 3, 5, and 7. And recall that odd numbers are numbers that are not divisible by 2. For example, odd numbers can be 3, 5, 7, 9, 11, etc. And even numbers are numbers that can be divided by 2. For example, 2, 4, 6, 8, 10, 12, etc. Question 8. The sum of 5 consecutive odd numbers is 45. List all the 5 odd numbers. For question 8, we can use guess and check. So, maybe we can start with 1, 3, 5, 7, and 9. And these are all odd numbers, and they are consecutive because they only differ by 2, differ by 2, differ by 2, differ by 2. But what is 1 plus 3 plus 5 plus 7 plus 9? It turns out that the answer is 25, which is too small because we require the answer to be 45. So let's increase the numbers. So we can start with 5. The next odd number would be, we can start with 3. The next odd number would be 5. The next would be 7. The next would be 9. And the next would be 11. And the sum is 3 plus 5 plus 7 plus 9 plus 11, which gives us 35. So we are getting closer now. So again, we increase the odd number to 5. And the next one would be 7, 9, 11, and 13. And 5 plus 7 plus 9 plus 11 plus 13 is equals to 45, which is correct. Therefore, the 5 odd numbers would be 5, 7, 9, 11, and 13. And they are consecutive because they only differ by 2. For question 9, Mrs. Lim arranged 12 pots of plants alongside a square garden so that there are 4 pots of plants on each side. So can you draw a picture to illustrate the arrangement of the pots? And this is our answer. From here, we see that for this side, there are a total of 1, 2, 3, 4 plants. And on this side, there is a total of again 1, 2, 3, 4 plants. And for here, there are 1, 2, 3, 4 plants. And for here, there are 1, 2, 3, 4 plants. And we check that there are a total of 12 plants. For question 10, let's label the gold bar as A, B, C, D, E, and F. Suppose A is the lighter one. And we're supposed to find out that A is the lighter one by using the balance as little times as possible. So for the first step, we can compare C, D, and EF. In the worst case scenario, CD would be equals to EF, so they would be the same weight. And no conclusion can be made. So which means we must use the balance another time. So now, if CD and EF are the same weight, it means that none of them is the odd one out. So now, let's compare B and C, keeping in mind that C is not the odd one out. So in the worst case scenario, if B and C are the same, again, no conclusion can be made. But now, we know that B, C, D, E, and F must be the same weight. Therefore, the odd one out must be A. And it would take us a total of 2 times to use the balance. Therefore, the answer is 2 times.